So how the enterprise agentic AI system is defined? So my definition is pretty straightforward. It should be a governed system that understands a business goal and follows an approved execution plan. And it should also use authorized tools along with trusted enterprise knowledge and also escalate important decisions to the right human authority, right? Everything around that, revolves around six pillars, basic six pillars. So it should have clear goal, it should have planning and reasoning, controlled tool usage, and grounded enterprise knowledge, along with governance and guardrails, and finally, accountability, which can be completely traceable and auditable. So, hello and welcome everyone to this LinkedIn live session. And we are today here for basically for a LinkedIn live session on enterprise agentic AI for insurance industry. So myself, Manish Kumar, and a little about me. So I'm Microsoft certified agentic AI business solutions architect, and I'm also a global leader in career bytecode. And I'm a founder of AI Empower Hub, which is a community, initiative from my end. And I have a total experience of 13 years in the enterprise technology solutions and basically data analytics and architecture. And in that, I have worked on Microsoft Azure and Power Platform, Tableau, and MicroStrategy overall as a different tools and technologies. And I have designed multiple client-based solutions for 25 plus clients, which move from the AI experimentation to a production like grade implementation for client. And my expertise include agentic AI architecture and also Azure AI Foundry and Azure AI services, including OpenAI, Azure Key Vault, and Azure Cosmos DB, Azure SQL, everything uh, overall in the Azure ecosystem. And I have the certifications also, I have gained certification from Microsoft, including the certification for Agentic AI Business Solution Architect and Azure AI Engineer, and also Power Platform Developer. And in my offerings, I provide enterprise consulting and also one-on-one calls for detailed discussions on enterprise solutions, including agentic AI and data analytics and BI solutions. So that's a little about me. So we will move forward and we will see a little about Career Byte Code uh, community. So it's a global tech community ecosystem which comprised of 2.4 million learners across 107 plus countries, and 1,000 plus mentors are included, which are technological leaders and global implementers. And who's there in the community? Basically, from in the community, if you see, we have enterprise architects, we have AI engineers, we have cloud DevOps leaders, and cybersecurity experts, including startup founders and technical CXOs. So that's about Career Byte community. So after that, we will discuss why we have gathered here, right? So what's the goal of today's discussion? So before jumping into the architecture and demos, I would like you to, get aligned what we are trying to achieve here. So the first thing we want to define is basically the difference between a co-pilot and a true enterprise agentic AI system. And then we will look on the production ready Azure reference architecture. And after that, we will be walking through a live insurance claim workflow, which I have implemented so that you can see how the multiple agents are collaborating together and how everything comes together in the hands-on demo. Okay. So usually what happens in enterprise agentic AI implementation, what's the reality, ground reality? You know, when I talk to different organizations which are working in the insurance industry, they don't need a chatbot. Basically, what they need is basically coordinate work along, alongside dozens of disconnected system. Because if you see at an enterprise level, there are multiple systems, multiple source systems, data systems, even CRM systems, all the document repositories, all the fraud engines, emails, everything needs to be coordinated and bring together for a enterprise level implementation. And every claim, whatever comes for an insurance industry, it has its own FNOL reports, it has its own invoices, repair estimates, and policy reports, right? So if you see, these are the different challenges which the enterprise faces. It's always a document heavy, and every particular action, whatever you take, has a consequence and a risk involvement, right? So apart from that, if you see, initially when the AI era began, everybody tries to implement a traditional co-pilot or a chatbot kind of an interface where it will respond to a prompt. It will basically drives according to whatever you give the input as, and it will draft you a good content. But it has a limited process state, and also the value is only individual productivity. So how the enterprise agentic AI system is defined? So my definition is pretty straightforward. It should be a governed system that understands a business goal and follows an approved execution plan. And it should also use authorized tools along with trusted enterprise knowledge, and also escalate important decisions to the right human authority, right? Everything around that revolves around six pillars, basic six pillars. So it should have clear goal, it should have planning and reasoning, controlled tool usage, and grounded enterprise knowledge, along with governance and guardrails, and finally accountability, which can be completely traceable and auditable, right? So that those are the basic six pillars of any particular enterprise agentic AI implementation. So this we already covered. So where do we apply these agents, right? So where exactly these particular agents can be used. So if you see over here, I have listed down some of the use cases where you can apply the AI agents. So you can apply it, the AI agent, for a new business where the agents can validate the submission completeness, and it can be also applied for underwriting where they can summarize all the risk involved for underwriting. It can also be implemented for claims, what they prepare as an evidence package. It can also be implemented at a fraud level where they collect all the fraud signals. It can also be implemented at a servicing level where they automate the request handling. And inside every contact center, they can be used for preparing summaries and recommended action. But the action and the authority to take action will be always controlled by a human in the loop. And that's where the enterprise architecture stays. So after this, we will look at what are the six design choices which we need to keep for an agent to be useful and governable, right? So these are basically your architecture principles which you should be applying whenever you are going for a agentic AI implementation. So number one is the system of records should stay authoritative, right? For example, if you are having system of records including policy, including claims, or including payments or any customer data, it should always remain as the source of truth, right? The second one is the agent should never receive unrestricted database access. It should never have a generic access, right? For example, if you give access to a tool where it is not supposed to access, and basis of that action, the agentic AI, whatever you have implemented, take some action, but it will not be valid. So you need to provide proper guardrails and also access controls on top of that agentic AI to make sure that it has never has an unrestricted database access, right? And also it should be having a defined flow, right? It should have a defined flow from end to end. So every particular action or a retrieval, whichever is taken by the agentic AI, it should always be defined before implementing the agent. And next one is the rules should be always deterministic. Because if you see the chatbot or a co-pilot, The rules are always defined in a prompt, but that should not be the case of agentic AI. The rules should be defined using a SOP document, the standard operating procedure document. And basis of that only the agentic AI should take the action, right? And it should be always deterministic. It should not be probabilistic. It should be deterministic. Like a step one is this, and then after that is step number two, then after step number two, three, and so on, right? And the fifth one is the humans should own the material decisions. There should be always a ownership of a human involved in the loop of the entire system, whatever you are implementing. And always, if you are making any material business decision, it should always be with a human. And finally, the most important one is all the action, whatever the agent is taking or the humans is taking, whatever may be the action, every action should be logged with a complete traceability. So these are the six key principles based on which you should design your architecture. So let's see how the architecture looks like for Azure. So this is only a reference architecture where we are defining the control plane around a multi-agent insurance workflow. So where you can see that the Power Apps is being used as an experience layer. Orchestration is with a Foundry agent service. The specialized agents you are defining with an intake agent or a coverage agent or a fraud triage agent or a communication agent. And your knowledge source is defined by Azure AI Search and Document Intelligence using reports and forms. And your action layer is defined by API management at a core system like PaaS or claims or CRM, right? So all of this defines your basically your Azure reference architecture, and where the control plane, which is basically in the Azure security and governance layer, you have Entra ID, Key Vault, Microsoft Purview, private networking, your private net, and Foundry observability and Azure monitoring and application insights. So these are the basic components which is defines your Azure reference architecture. Okay. So I'll give it a pause, and if you have any questions, you can put it on the chat or you can unmute and speak. Till here, any questions or any doubts or any confusions? Amit, Hafsa, Viveka, anything? Which API is best to use? So you need to use RESTful APIs. Those are the standards, right? So every particular system which you're integrating can have multiple APIs exposed using RESTful APIs. And also, if the APIs are not exposed, for example, it's a legacy system, then you need to use a RPA to integrate it. So RPA is nothing but your hosted bots, which will interact similar to a user interface, and then it will take the data from the legacy and import it to your agentic AI system. Okay. So that's how you can integrate it, the third party integration. Okay, great. So that answers your question. If there are no further questions, we will move forward. So how does the multi-agent operating model works? You know, so how it implements is rather than having one massive, agent, one single agent is always not recommended. Because if you have one massive prompt trying to solve every problem, we will not be able to define the accountability or the traceability of each and every action of a specialized agent. So what we need to do is we need to divide responsibilities across specialization. For example, the claims orchestrator will coordinate the entire workflow. Your intake agent will extract the structured information from the uploaded documents. Coverage agent will define what is the policy coverage according to the enterprise knowledge. Your fraud agent will define the evaluation of fraud indicators. And your approval agent will define the approval for the adjuster to see and the decision to take based on the approval adjuster package. Right? All of that should be with the specialized agent, and accordingly you can combine this agent using an orchestrator, right? So the next one is basically how do you select where to use what, right? Basically, how do you define the decision rights? And this slide is probably the most important slide out of the entire session. How do you define where to use agent, where to use human in the loop, where to use autonomous agents, where to use semi-autonomous agent, right? So I've given in kind of a matrix here. So for autonomous agent, how does it use? Like where you have a low risk activities, right? So what are low risk activities? For example, you need to extract fields from a document. That can be autonomous, activity. You need to define, draft the claims for a particular customer. The first draft can be an autonomous activity. You need to acknowledge a customer with a standard response. That can be autonomous, right? For human in the loop, what you need to do is you need to define human in the loop where places like you need to take a coverage decision, right? Or if there is a denial of the coverage, those decisions should be always with the human in the loop. If you need to settle a particular claim, those decisions should require a human in the loop. And also the deterministic calculations like deductibles, eligibility, all of this should be always defined with a human in the loop, right? So these are also human in the loop, but these are deterministic only, where you need to define some kind of a value or some kind of a approval to make the things move to the next step, right? And human in the loop is not just another approval button. It's a ownership and the authority which is delegated to a human, and it should be always backed by a evidence. The human in the loop should basically review whatever evidence the agentic AI system provides, and the human who is approving that would be accountable for taking that decision. Because most of the time, what happens is when you implement any agentic AI implementation, right, you need to have the ownership and the accountability to be stayed with a human, right? And it should be fully auditable in terms of the action log or the audit log, the entire decision process, right? I see one question there in the chat. How is the operating model boundary enforced technically at the runtime? Through scope tools, policy rules check, and delegated approval authority, and an auditable record of each handoff. So, operating model boundary, how it is enforced is by proper guardrails and the handoffs, which I have mentioned here. Those need to be defined in the agentic AI implementation itself. Like how you will be giving the proper access to particular tools. For an agent to take action, they need to do the action based on certain tools. The tool should have a, you know, some kind of a boundary defined around that tool so that it can take only restricted action. It cannot take like any action, only the actions which are approved for that agent or approved for that tool. So those things you need to define in the agentic AI system. And those things initially in the Copilot, they were defined in the prompt itself. But now how you can define is you need to define it using the enterprise RAG or the SOP document. So you will be giving the SOP document to a RAG interface where it will be indexed and everything will be, input. And using those inputs, you will be uh, basically instructing the agent to see those inputs, and based on those inputs only you need to take action, appropriate action. And that's how you do all the policy checks, all the rules and all the definitions to be implemented in the agentic AI system, right? And how the delegation happened, right? So delegation is basically when you are taking some action, the agent is taking some action. Some action which are low risk can be taken autonomously, but few action which require some kind of a decision or authority will be given to the delegated to a human authority. So agent will be instructed that you need to wait for certain action from the human. You need to wait for certain input from the human. And based on the input only, you need to take action. The next one. So that part will be defined when you are defining the entire workflow of the agentic AI system. In the workflow itself, you need to define all these steps. That step one, this, step two, this, and after step two, you have a human in the loop where human will take decision, right? And all of this will be audited, right? Because you need to take the audit log for every action which is taken up in the enterprise AI system. Okay. And the auditability will be happened in Microsoft Azure using application insight. So you have a monitoring tool which is called application insight in Microsoft Azure, which takes care of entire observability and traceability, right? So everything can be monitored at a single place. Hope that answers your question, Amit. So let's go through the hands-on session. Yeah, thank you for asking as well. And let's go through the hands-on session. Let me share my screen. So now we have covered the enterprise agentic AI architecture and the technology stack. Now we will see it in a real business problem. So this demonstration is based on a motor first notice of loss (FNOL) process in the insurance industry, right? So imagine an insurance adjuster who has just received a new claim, and the adjuster uploads the claim documents into a platform, right? And these typically include the first notice of loss report, which is a FNOL report, a repair estimate, and a police report and a vehicle damage photographs. All the supporting evidences, basically. And from this point onwards, Enterprise Agentic AI will basically process all of these documents, orchestrate it, and complete the entire claim flow. Using the Agentic AI implementation. So our objective here is simple. We need to transform all the raw documents into an evidence-backed, adjuster-ready claim package within minutes. Because usually, if you see from the traditional insurance industry, it usually takes about a couple of days to couple of weeks even to process all of these documents. So one thing I want you to notice is throughout this demonstration, AI will never settle the claim. It will never approve any payments, and it will never override any policy rules. Right? Instead of that, what it will do is it will coordinate all of your documents, all of your enterprise knowledge, and all of the deterministic APIs from the third-party systems, along with the business rules and specialized AI agents, right? And while keeping all this, the adjuster will be completely in control of this claim. And that's the difference which is there between an enterprise AI and an autonomous AI, right? So before we begin, let me explain you the demonstration environment, like how we have done the setup for this entire enterprise agentic AI implementation. So everything what you're about to see is completely based on a synthetic insurance data. There is absolutely no real customer information here. And the claim package contains a realistic insurance document, which includes the FNOL report, the repair estimate, police report, vehicle damage images, and also a policy schedule. Along with that, you are also providing it a previous claims history, right? So instead of connecting directly to the production system, the application communicates with the sandbox enterprise APIs, and these will be simulating the policy administration as well as the claim system while returning a deterministic responses, right? We are also making sure that we intentionally introduced a conflicting information into the data set. For example, in this particular process, what we have introduced is we have included couple of fraud indicators, which basically provide you an indication to the adjuster that there are some fraud claims in the history which is made by this applicant. And based on that only, the adjuster need to proceed. And everything will be, you know, demonstrated in the next couple of minutes, where the AI will handle all the uncertainty, it will validate all the evidences, it will follow all the business rules, and it will also recommend escalation wherever it is required. So let me show you quickly how the application looks, and we will go through the actual hands-on demo now. So if you see here, this is the actual implementation in Visual Studio Code. So if you see here, this is the actual implementation in Visual Studio Code. And here we have all the required modules for the Enterprise Agentic AI implementation, including a front-end module, which includes a React.js implementation, and a backend module, which consists of a Python fast API implementation. And all of this is basically based on a Azure AI services, the Microsoft Azure tech stack, which I'll be explaining in a couple of minutes. So first, what I need to do is I need to start the servers for basically, demonstrating the agentic AI platform. So the first thing I will start is I will start the front backend server. So I need to run the command npm run and then dev backend. So what it will do is it will initiate the backend server, which is a UVCon server hosted on a local port and uh, your local workspace. And the next thing what I need to do is I need to also initiate the front end server. So for that, I need to write npm run dev front end. Okay, so once both the front end and the backend servers are running, I can take the local address from here and then start it in a particular local, instance. So the address we can post it over here, where it is going to be executed on a local instance. The first thing is it will ask for an authentication. So what I have done is I have integrated this with a Microsoft Entra ID authentication layer, which will authenticate based on your role-based access control related to your Microsoft login credentials. So over here, we have three personas. We have the admin persona, we have the underwriter persona, and we have the adjuster persona. So these three personas basically will be the different roles which will be playing for this claims processing. So let me enter my admin persona. So it will ask for a confirmation once you sign in using the Microsoft credentials. So all of this will be accessed based on your persona. So as you can see on the top right, I am logged in as an admin persona, right? So admin persona will have all the accesses to all the modules, right? I'll later on show you the underwriter and adjuster persona as well. So let's see the dashboard. This is the landing dashboard, which will be there for the Agentic AI Studio for insurance. So in the dashboard, you can see how many total claims are processed, how many claims are in progress, how many agents run you have done, how many human approval queues are there, and what is the average processing time, token usage, total number of API calls, and agent health. And also you can see the latency and throughput in a real-time basis for the last rolling 15 minutes live telemetry. Okay. So let us process a new FNOL case. So over here, we have to go for the new FNOL case in the second tab. And in that, we need to put all the policy details. For example, we need to put the policy number, customer name, incident date, location, vehicle registration, and report channel. And all of this will be supported with the documents. So I'll just first upload the FNOL report. So I need to locate where is that FNOL PDF. So after that, we need to also upload the repair estimate and the police report. And finally, we need to attach the vehicle images. Okay. And then click on prepare triage package. Now, one by one, this FNOL report, repair estimate, and police report and vehicle images will be uploaded on the backend storage, which is a Microsoft Azure blob storage. And then it will start processing. The first step is analyzing the document. So the documents will be analyzed using Microsoft Azure AI document intelligence module, where it will process all the four documents, including the three PDFs and the images. And once this document processing is completed, it will move on to the next step, which is the claims intake agent. Okay. So if you can see over here, all the documents are being processed along with whatever is the PDF content of that document, each PDF content and the image as well. Okay. Once all of these documents are analyzed, it will go on to the claims intake agent. So in the claims intake agent, which will be basically, it will understand all the documents, and this agent will basically create a digital claim record. Okay, so if you can see over here, we have the claim number, which is again generated by the claims intake agent. We have the policy number, we have the customer name, everything, incident date, when that incident took place, and location, vehicle registration number. All of this information is gathered from the all the PDF, which is analyzed by the document intelligence agent. And after that, it will consolidate all the extracted information. It will validate if there are any mandatory fields available or missing, and it will identify all the document completeness and create a standard claims package for the coverage agent, right? So this will eliminate basically if there are any duplicate data entries or also reduce the manual effort which is required to go through each and every document. So that's the purpose of claims intake agent. Now the package from the claims intake agent, it will go to the coverage agent, which will determine the policy eligibility, and it will retrieve the policy schedule. It will get that from the Azure AI search, which is a RAG engine. And it will also check the coverage clauses, if there are any exclusions or deductibles, all the standard operating procedures for insurance policy claim. And it will also call deterministic enterprise APIs, which will validate the policy status and the coverage. And you can notice that the language model is not deciding whether the claim is covered or not. It is depending on the policy coverage document, which is uploaded in Azure AI RAG engine. And based on that only deterministic rules, it will be only calculating the claim or the coverage package. Okay. And official, if you see, the enterprise systems perform these validation manually. But right now, that is AI augmented, and it is based on the deterministic rule based on the Azure AI RAG engine. And the AI will basically retrieve all the evidence, it will coordinate the workflow, and it will present the recommendation. Okay. So after this coverage agent is completed, the coverage agent will provide the coverage package to the fraud agent. So what the fraud agent will do is it will evaluate the claim against potential risk. It will analyze all the previous claim history. It will identify if there are any suspicious patterns or detects any conflicting information, checks, regarding fraud indicators, or evaluate any overall, claim consistency. If there are any issues or any miss or any checks or any, problems with the claim package, coverage package, right? And after that, if there are any additional investigation required, it will recommend an escalation, right? For example, if you see here in the approval step, you can see there is fraud signal here. So what is this fraud signal saying? That there are two SIU flags detected. So what is SIU? SIU is nothing but your special investigative unit, which is a team which verifies if there is a issue with the claim, and all of that will be flagged over here by the fraud agent. Okay. So after the fraud agent is done, it will create the entire complete package for the approval agent. The approval agent will finally create a registered adjuster ready triage package, and it will also give all the information whatever is covered from all the previous agents like claims intake agent, coverage agent, and fraud agent. Right. This package will include all the extracted claim information, all the supporting documents, all the policy validation results, all the coverage analysis, fraud assessment, any missing information, any enterprise API responses, also a AI recommendation. If you see at the bottom, what is the AI recommendation? It is asking for a review process for a human approval, and this will complete the entire triage package. And instead of navigating to the multiple system, the adjuster can now come to this platform and he can see the consolidated evidence backed package and then accordingly act upon it. So what the adjuster can do is it can either approve that package if he has the required information. It can he can also reject the package. He can also assign the package to SIU team, and if there are any additional required documents which are missing, it can request for the document. Or if there are any additional tasks to be created, post this, everything the process is done, he can create the task. So in this case, we will just approve the process. Once the process is approved, what it will do is the next step will be for communication agent. The communication agent is based upon the adjusted action. It will communicate back to the customer what is their action and what they need to do next. So as you can see here, the communication agent will be sending an email to inform the customer back that your claims process is reviewed and approved, and the payment will be processed between 5 to 7 business days. Okay, so this will be the entire flow for the claims processing. So what are the key takeaways from this? Is the enterprise agentic AI is not a single intelligent chatbot. If you go from the chatbot perspective, it's not a chatbot. It's a team of specialized AI agent who are working together, and each agent is responsible for a specific business capability. Right? For example, if you see the document intelligence agent understands the document, claims intake agent creates the trusted digital claim package, the coverage agent validates the policy eligibility, and also using the deterministic APIs, it will check the enterprise knowledge. And then the fraud agent evaluates the risk and recommendation for the escalations. The approval agent prepares the complete evidence-backed triage package for human review. And finally, the communication agent will deliver it to the communication to the end user customer. So here the AI is only coordinating, right? The enterprise system just validate everything, and the adjuster is the one who will decide the final, output or the outcome of the entire process. And this is how the modern organizations are moving from isolated AI experiments to the secure, governed, and production ready enterprise agentic AI solution on Microsoft Azure. So next, I want to show you the different modules which I have implemented. So the next one is the agentic studio, where you will be able to see how the claims are processed by each of the specialized agent. Because one of the biggest question in enterprise agentic AI implementation, the leaders will ask that what exactly each AI agent is doing in my system, right? And this is where the agent studio comes in place. Here you can get for every specialized agent its own prompt. What are its responsibilities? What are the different tools available for this particular AI agent? Okay, what is the latency, average latency? What is the confidence percentage? How many tokens it has used? So all of this will be consolidated, and it will also show what is the JSON output format for this particular agent, right? So all of this is transparent and available for the end user or the admin persona to look at. And similarly for the other agents like coverage agent, fraud agent, approval agent, and customer communication agent. For every particular specialized agent, you can see. Next is the orchestrator. So what does the orchestrator do? So it will show how these agents, these specialized agents, are actually working together, because that's being handled only by the orchestrator. So instead of agents calling each other randomly, every execution is coordinated centrally. And here we can see the execution graph where the claims intake agent, coverage agent, fraud agent, approval agent, and customer communication agent all are executed in a sequence. And below that, we have the activity log where we can see every event, every decision, and every tool call and every response. It is captured in a chronological order. And we can also see the output of each of the agents finally over here in the right hand box. And after this, the next module I have implemented is integration. So integration is a very crucial, part of any enterprise agentic AI platform, because no enterprise AI platform can live in isolation. It needs to be integrated with dozens of enterprise systems which are residing in different applications and platforms. So here we want to showcase some of the common integration patterns using RESTful APIs, event-driven architectures, which are basically Kafka and webhooks. And also, if there are any legacy applications, applicable for to integrate with this platform, they can be integrated using RPA. And we can also integrate the industry standards like Accord, EDI, all the industry standards for your document and data exchange. Okay. And the AI agent will never communicate directly with these platforms. It will be always governed, and whenever we are integrating with any third party tool or systems. The next module which I want to cover is the knowledge center. So the knowledge center is basically in any of the enterprise AI, one of the biggest reason why it fails is it doesn't know where the organization knowledge is, right? And that's where the knowledge center comes in place. It is powered by Azure AI Search, and we can query the insurance policies, coverage documents, uh, you know, all the underwriting manuals, or any particular enterprise knowledge source which is uploaded and indexed in the Azure AI RAG engine. So here you can see that if I click on the policy schedule, it will give me what is the policy number, who is the policy holder, vehicle registration, and all the information which is available in the Azure AI RAG engine. And uh, this is where the hallucination can be avoided for AI agents, because most of the time, if the AI agent is not grounded on the enterprise knowledge, it will hallucinate, and all the relevant information is basically captured from this RAG engine, and all the responses of the agents are grounded based on these knowledge source. So all wherever you can see that we are also providing the citations here. So where we have taken this particular information, from which particular page, all of that will be provided over here in the knowledge center. And it will be also providing what is the accuracy percentage. So if you see over here, the policy over page number has an accuracy of 100%, but others are having less than 100%. So the knowledge source will also see that what are the different accuracy of the different result. Now, accordingly, it will give you the result. And the next module which I have implemented is the API Explorer. So API Explorer, because we need to integrate with third-party systems in an enterprise, scenario. Here we can see there are different APIs available out of this platform, which can be integrated with a third-party system. For example, we have a claim eligibility API, right? You can check and execute this one and see what is the latency, what is the rate limit, and all the authorization, because it's a managed identity authorization. So what is the request JSON and what is the response JSON? All of this will be available in the API Explorer, which can be used for testing all the APIs which are available out of the box from this platform. And next one is a governance center. The governance center is the crucial one where you can see the live information for your identity, access control, and all the audit trails, right? So over here, you can see that different modules are being implemented here. For example, identity using Entra ID, role-based access control, audit logs, human approval, All of these are implemented, and there is an audit trail which basically runs throughout the system, which is a immutable trade, append only trade trail, which will basically run across the entire system and capture all the actions and the logs across the platform. And why it is important? Because if you see the enterprise AI, the enterprise, implementation or the building of the AI application is quite easy, but operating it at a very secure level inside a global enterprise, that's where the real challenge comes. Because if you can see here, we are using the identity management using Microsoft Entra ID, role-based access control, human approval workflows, and audit logging. Everything here plays an important part to making this platform secure and enterprise scalable. And we have also designed the prompt shields, data classification, prompt injection protection, content safety, responsible AI controls, which is equally important. Every important action, whether it's a document upload, agent execution, or a human approval, is fully traceable using this governance module. After this governance module, the another important module which I want to cover is observability, which is based on Azure AI Foundry, application insight, open telemetry. So enterprise AI really needs enterprise monitoring, right? And this dashboard provides the real-time observability. We can monitor here, for example, we can monitor latency over here. We can see the token consumption. We can see how many total agent calls, what is the agent activity, over the period of time. What is the tool call versus failures? And all the data is streamed live from this, right? For example, we ran a claims processing in past few minutes. That itself is only showing over here, right, on a live basis. So for that we had a token usage of almost 713 tokens, and the agent also called for a couple of times here, as you can see on the agent calls. And all of this information becomes important from the observability perspective, which will even give you enterprise level monitoring. And this is critical for production AI systems, because operation teams using this observability tool only can monitor the systems, and it can detect they can detect the issues which are happening inside the system on a live data, right? The next thing which I want to share is the evaluation module, which is basically tracking all the groundedness of the data, all the tool accuracy of the data, because every AI interaction which is happening over here need to be monitored continuously and evaluated as well. So here we are monitoring the task completion status as well, the hallucination rate, and the citation coverage and the human override rate. So all of these metrics is equally important, which will basically allow the organization to continuously improve their AI systems over a period of time. Because it's not a one-time implementation. Once you implement, that's only the beginning of the stage. Over the period of time, as the consumption increases, as the usage increases for any particular enterprise platform, it will give you different types of issues over the period of time. And that thing only can be done and pre-tested using this agent evaluations, right? This will give you an idea what can go wrong for using this enterprise platform. And after this, I want to cover the enterprise agentic AI architecture. These are the different modules which I have used from the enterprise architecture. For example, for experience, we are using React Admin Studio. We are using the API and gateways as fast API backend implementation. For orchestration, we have used a pipeline orchestrator and human in the loop gates. So everything here, whatever you see, is a layer for this architecture: the agent layer, the AI platform, and the knowledge and RAG layer. And after this, I want to cover the final section, which is the Azure services, what we have implemented. So over here, what you can see is the entire set of services what we have used. We have used Azure OpenAI, for example, for AI and LLM generation. We have used the Azure AI Foundry. We have used the Azure AI Search for enterprise RAG. We have used the Azure Document Intelligence for document extraction. Azure AI Blob Storage is used for evidences and the document storage. Azure API management is used for securing the APIs. Azure functions and logic apps are used. Along with that, we are also using Cosmos DB for data storage. We are also using the Azure Service Bus and monitoring to make all the monitoring capabilities to be integrated along with application inside Azure Key Vault for storing all the API keys and the connection string, and Entra ID for security purposes, uh, and Azure SQL for data storage. So all of this, which you can see over here, is done for the global deployment at an enterprise level. So that's the complete end-to-end journey from a customer submitting a claim to the autonomous multi-agent processing, right? What we have seen through here, which includes a human approval, customer communication, governance, observability, evaluation, enterprise architecture, all the way down to the Azure platform services powering everything underneath that. And this is not just a chatbot. It's an enterprise agentic AI platform which is built using Microsoft Azure and designed for a secure, governed, and production grade AI at an enterprise scale. Yeah. So Amit and Hafsa, uh, we have come to the conclusion section. I'll just share. Uh, if you guys are able to see the QR code and the Q&A section. So I put my questions in the Q&A, didn't want to interrupt the flow. Okay, no problem. So you can put your questions in the Q&A now if you have any questions. And also if you want to, revisit the live application, I have it running on the backend. If you want to see it again, that's also fine. We can review it together, or if you want to go through how we have implemented, or if you have any questions in terms of the implementation, like what particular things are being used or anything, uh, I'm happy to help you.